This is the question taken from EdMath book. It's a question number 14 from exercise 13.5, and the chapter name is vector. In that stage, question is written here: position vector of A and B relative to origin O is given twice I minus 17j, and position vector of B is given 6i plus 2j. First, it is written here like the vectors we did previously. Similar method I am going to apply here. They ask you to find out the vector AB. So AB, if we going to write with the position vector, we can write directly OB minus OA. In that stage, OB is given here 6i plus 2j. We are going to write 6i plus 2j minus OA vector is minus 2i, so we can write here minus 2i plus 17j. So we got from here 6i plus 2j, then remove the bracket, then inside the sign we have to change plus 2i, then minus 17j. So finally we got from here 6i plus 2i, which is 8i, and 2 minus 17, it gives us minus 15j. So this is the vector of AB, and answer of this first question 1. That is the AB vector. Second question is written here: find the unit vector in the direction of AB. We can find out the unit vector we can say, if we divide AB with its modulus, then we can find out the unit vector. AB vector divided by modulus of AB vector. This is called the unit vector. So our vector is 8i minus 15j divided by its modulus. So we know that, which we can write 8 square plus minus 15 whole square. Minus 15 we needed to put inside of the bracket. So then it is 8i minus 15j, and bottom one, let me check with our calculator what is the value comes out here. This is our calculator I'm going to use on the right side of our board. Yes, so we have to erase first. Okay, root over 8 square we can write here root 8 square, then plus minus 15 whole square. You also can write 15 whole square, same thing, minus 15. It is written here minus 15, but if I write there 15 whole square, you will get the same value from here. Let me check. Oh, it's the value given as 17. So now we can write individually, which is 8 by 17i, then minus 15 by 17j. That is the answer of this question. Hope it is clear. Then the third question is a common question in every single question. In third part, they ask you to find out the constant or something like that. The position vector of C relative to the origin OC equals to, that is equation given, OC equals to OA plus MOB. M is a constant given that C lies on x-axis. Find the vector OC. That is the question. So we can write the whole expression like OC equals to OA plus M of OB. Let me write first. OC equals to OA plus M of OB. So OA is our vector given OA minus 2i plus 17j, then plus M of OB is given the second vector 6i plus 2z, 6i plus 2z. We can write by taking I common. If I take I common, then it would be minus 2 plus 6m, and another part, if I take j common, then you can write it 17 plus 2m. So both of the vector in terms of in terms of m, we can write OC. This is the OC. Here one important thing is written here, C lies on x-axis. What does it mean? If I draw a diagram on the right side, say C is here, O is here, so OC means definitely there is no z component here, only here the component I component is remaining. So you can say OC, definitely it would be like constant I. Any constant is here, we don't know what is the value of the constant. In that case there is no j component, so we can say j component is 0 here to make C as in the x-axis. So we should consider here component of z, which is 17 plus 2m. Let me write here j component as a 0, 17 plus 2m equals to 0. So we got from here m equals to minus 8.5, because 17 by 2 is minus 8.5. Now we can write our OC vector. M is a constant, we got the value of m, and OC vector we can write, therefore OC equals to, let me put the vector, minus 2 plus 6 into minus 8.5, so which is I minus 2 minus 17, it gives us minus 19 I. So this is our vector 19. I hope you understood this question. It is from Cambridge Mathematics book, exercise 13.5, and it's a board exam question and also important. Thanks for watching.